Hello everybody, I'm Nick, and in this video I'm going to show you how we can start writing integration tests in ASP.NET Core. Now, there's a reason why I'm not going into unit tests now and I'm going straight into integration tests. It's because it's probably what you're not as familiar with, since this technique was only recently added, and I do say recently, it's more like a year since 2 point something in ASP.NET Core. So we're going to go through that first, and later in the future we are going to talk about unit tests. And if you want to see more like this, please subscribe and leave a like, or just comment down below what you want me to show you in a future video. So let me just go straight to the point. What is an integration test? So integration tests is a way to ensure that your application can actually function properly while communicating with other components in the system. That might be the database, the file system, networks, or other pipelines that you might have set up in your application, such as middleware. So the way we're going to go about it is we actually are going to be hitting a running application. Our API will be running as normal. The only difference is it's going to be in memory as part of the testing. And we're going to use a unit testing framework to integration test our API. So I'm going to show you how to do this. It's a very cool and nice way to get started with integration tests. So first and foremost, you want to go and create a new project. I'm using Rider here, so as you can see. So I have this creation project window. You might have a different one depending on your IDE. So I'm gonna just go ahead and say tweetbook.integration tests. And that's just a naming convention I'm gonna use. You can use your own, of course. So we create that, and you can see that there's just a blank test that has nothing. If I open my testing window, which should be here, you can see that I have this view, and I can just select this and run my tests, and I expect this to pass. And that's just a normal unit test using XUnit. What we are going to do is we are going to spin up the application and target this application. So run code against our running API. So the way we're going to do that is using something called the WebApplicationFactory. And that's something added in 2 point something in .NET Core. And to actually use that, we do need several packages. First and foremost, we will need a package called Microsoft ASP.NET Core MVC Testing. Let me just go ahead and add that. And we will need the ASP.NET Core.app package that has a lot of packages in it. So it's like a collection. So we need both of these. So as we wait for these packages to install, I'm gonna go ahead and show you how this thing works. Now we're gonna delete this whole class, but I just wanna show you how it will work before I go and implement this thing the actual way. So we're gonna have an HTTP client. Let me just name this client. But this is a special HTTP client. Will be coming from this new class I talked about, which is the Web Application Factory. So if I do app factory equals Web Application Factory, and this accepts a startup class, so I'm going to use my application startup, and obviously it cannot find it because it's not referenced. So I'm going to go ahead and reference my Tweetbook application. So startup, and I have my database running as well. So if I do create client, just like that, I'm creating an app factory. And if I do app factory.create, so sorry, I already created the client, so I don't want to do that. And if I do app.create client, here what I get back is an HTTP client, which is a very interesting one. It will have some base address, but that won't be used. This is an HTTP client, a special one that knows how to target an in-memory version of this project, which is whichever project the startup belongs to. So let me just go ahead and show you in practice what this will do. Let me do a get async on an API routes dot, let's say post dot get. And this should accept the post ID, so let me just replace that and say replace post ID with whatever one. And let's get a response back. So I'm gonna change this to an async task. Let's take a breakpoint here and just run it and see what I get. So this goes into our unit test constructor, and that will be very interesting because I have the app factory, and the app factory has many things. It has a server which is currently null. It's a TestServer object. That's an in-memory test server. Then I have my configuration, some factories, and then I have some options here. As you can see, the base address is just this, but it won't really be used. The moment I trigger this create client method, you can see even in this app factory here that the server is no longer null. We have an in-memory server with this same base address that can only be accessed by this very HTTP client. And we are going to use this client, as you can see here, to just call this server as if it was a running application. And if I do that, you can see that I get an unauthorized, and that's because, well, my barrier token is not actually set. And that's what you'd expect from an API that's running without a barrier token. This behaves exactly the same way. Keep in mind, this is actually using this very same database here, the one we set up some episodes ago. And nothing is mocked. This is the real deal. It's just that the server is running in memory. This is a very interesting concept. What I'm going to do is I'm going to delete this. I'm going to show you how we can properly implement this and start integration tests for our application. So first and foremost, I'm going to do create an integration test class. And the reason why I do this is because all of my other test classes will actually extend this base class. And in the constructor, I'm going to set up my test client the same way I did in this video. This will be a protected read-only HTTP client, and I'm going to name this a test client, and I'm going to initialize it here. So again, app factory equals new web application factory, and then the startup of the application we want to run, and then test client equals app factory dot create client. Now, I won't go in depth on this app factory, but you're gonna see whatever you need to know about it. You can do more reading on yourselves afterwards to see there are many cool things you can extend here if you really wish to do. But I won't be showing everything here. So please, if you're interested, just Google it afterwards. So a nice convention I like to use for my tests is use the controller name, post controller, and then tests. I'm gonna create my test class to be posts controller tests because I'm going to be testing this controller, and this test class will be extending the integration test class. In XUnit, in order to test, we need the fact attribute. So I'm going to make a public async task, which a convention I like to use is the controller method name. So in this case will be get all, and then underscore, and then I'm explaining what I'm doing. So get all with empty or without any posts returns empty response, something like that. You don't have to follow this convention. It's just one of the many ways you can do it, but I do like to follow this one, at least for the tutorial. It's clean. And something else I want to follow is the AAA or arrange act assert, just to separate what I'm doing in this test method, so you can actually see clearer what I'm actually doing. So to arrange, first and foremost, we need to do some setup. Currently, the only thing we need to do is to just authenticate ourselves, because if I try to access this currently, I'm gonna get, as you saw before, a 403 unauthorized. So in my base class, I've just changed to protected as well. In my base class, I'm gonna make a method, and this method will be called authenticate. So I'm gonna make a protected method named, it's gonna be an async task, and I'm gonna name this method authenticate async. And let's just leave it here as it is for now. And what this will do is it will set the default header for authorization on our client, and it will actually be getting a JWT for our client. So I'm gonna do bearer, and then here I'm gonna say get JWT async, and I'm gonna create this method. It's gonna be again an async task which returns a string. I have to await here, of course. And this method, I don't know why this is not accepted. This should be invoked with, oh, of course, this is the wrong overload. It's a new value. Okay, so this is fine now. And now this should somehow return a valid JWT for my test. The way I will go about this now is just register a user. Since XUnit runs the test once per execution, so this class will be instantiated once per test essentially, this will be fine. Our user will be registered every single time we run the test. We could do setup and teardown, but we're using empty framework. Because we're using empty framework, we can cheat. Well, we don't really cheat, but what we really do is we just change our SQL Server database with an in-memory one. And this specific class has a very interesting way of going about it. What I'm going to do is I'm going to say after application factory with web host builder, and I'm going to say builder. And in this lambda expression, I'm going to say builder.configure services. And I have my services here. And these services are the services of this test server that we're going to spin up. At this point, our startup's execution has been finished. Everything has been configured up on at this point, and I can actually configure more stuff here. What I'm going to do instead is I'm going to say services.remove all, and I'm going to remove all types of our data context, because this is a data context that's using real SQL Server infrastructure. I don't want to do that. What I will do though, if Rider lets me, is do services.add context, and then add the data context, and I have some options here. And these options will say options.use in-memory database, and I'm gonna give this a testDB name or something. And now I have this set up, and this application now no longer uses this real database, it's using an in-memory one, meaning I can just register every time without any clear down and will just work. And this is a realistic representation of how your application will work. Now, if you need acceptance testing, you really want to test against a real infrastructure, you want to spin up Docker instances maybe, or just do teardown cleanups afterwards, but that's up to you. So in this method, I'm going to do var response equals, and I'm going to use this very test client to do a post as JSON async API routes, and I'm going to say identity.register, and I'm going to post a new user registration request, and this is a request to register a user for those tests to get a token back essentially. So test@integration.com, maybe, why not? And then password equals some pass 1234 exclamation mark, just an example. And at this point we have our registration response object, and I'm going to say await response.content. I have to await this, of course. .content.read as async, and I'm going to read it as auth success response. What I'm going to return back is the registration response.token, and I have my JWT here. So at this point, in order to authenticate my test, all I need to do is here say await authenticate async, and that's it. My HTTP client will be automatically authenticated. So let's see what the test looks like. We will do an await here and then test client, and I'm gonna do a get async with my authenticated client against the API routes .posts.get all. And what I want is to validate that this response is a 200 and my content is an empty list because there are no posts in the database to return. What I really like to do with my tests is use a package called fluent assertions. This package, exactly as the name implies, allows me to fluently assert my unit tests. Now with the package here, I can do response.status code should be, and then my status code, so http status code.ok, because that's what I want it to be, and then response.content read as, and that should be a list of posts should be empty. Assuming I did everything right, if I add this fact attribute here, my test will appear and I'll be able to run it and it should pass. Let me expand this. As you can see, my test is passing. It's doing exactly what I said it would do. If I change this and I say not found or not acceptable or anything else, my test should fail because the request or the response should not be what I want it to be. Exactly. See, it's not acceptable but found okay. So this is an integration test that is hitting an in-memory version of my application, which is using an in-memory database, not a mock, just an in-memory version to run integration tests. This is a very awesome feature and I really love writing tests this way. Let's see a few more, just so you get a better idea of what we're doing. So another thing I'd like to do is show you how you can actually ensure that the post is created and can be retrieved. So the test could be something like async task get, is it called get by ID? What do we name it? It should be get, okay. So get returns post when post exists in the database or the system or just exists. Naming can be whatever you want it to be. So first and foremost, we want to authenticate. So authenticate async. And now we need another method in our integration tests class. And this method will be called protected async task. It's going to turn a post response. It's going to be called create post async. And we accept a create post request. And we're going to use that to create one hitting the endpoint. So test client dot post as JSON async. Again, API roots, posts, create, nothing else needed here, and then the request itself. And I'm gonna get the response back, response, and I'm gonna return the response dot content dot read as async. And I'm gonna read it as a post response, which is what it is really. And if I actually await this, it should be happy. So that is fine now. I can go back to my test and say await, create post async, and I'm gonna create a new post with name equals test post. Keep in mind that each of these tests are running in isolation, so anything I create here doesn't affect anything I do here. If I wanted to test it this way, I would use an iClass fixture in this scenario, but we don't need to do that. It's equally as fast to spin up one server at a time. If you want to test more, you can, but I've noticed some disposal issues of my HTTP client if I use a class fixture here, so I won't show that. What I'm gonna do is I'm gonna do var response equals await test client dot, and I'm gonna do a get async. And what I'm gonna get a post, the post I just created. So replace here, and I'm gonna replace the token, the post ID token, to use the create post one. If I do say name ID, to string because it's a GUID. So I have the response here, and this should actually retrieve exactly what I want. So I'm going to say status code should be HTTP status code OK, because we retrieve something we created, and then await response.content.read as async. I'm gonna read it as a post, which is what it is. And let me just extract it here as return post, so I can do multiple assertions on it. So return post dot id should be, and it should be the create post dot id, and then return post dot name should be, and it should be the test post I have here. So if I build this and run it, both my tests should pass, again, unless I screwed up. As you can see, both of them pass, both of them work. You can take this even further. You can test that your creation is working. You test in a very similar way where you just have this in your act, and then your assert is the retrieval itself to see that it's actually created. But there's so many ways and so many things you can do. These are just the basics. As I said before, if you want to test against a real database, you just comment this out, and this will run against a real database, but you will need tear down or cleanup methods after the test is run. That's all I want to show for this first video. If you want me to go in depth on this, please leave a comment down below, and I'll make more videos on how you can run integration tests. Unit tests are on the way as well. If you want something specific, don't forget to comment about it down below. Leave a like if you like this video, subscribe for more content like this, and I'll see you in the next video. Keep coding.